Welcome back to Organic Chemistry Decoded, where we're breaking down organic chemistry so you can ace that exam. We have some more practice reactions here, and we're doing another round of predict the product. So with this reaction we have here, can you predict the product? So if you want, you can pause this right now, screenshot it, work through it on your own, and then come back, see if you got the right answer. If not, just sit tight. We're going to work through it together. So to start out, we have this molecule right here, which is known as potassium phthalimide, where this is a salt, which is there's a negative charge on the nitrogen, and we have the positively charged potassium. And then first we're going to react it with bromopentane, and then we're going to hit it with this right here, this NH2, which is known as hydrazine. So what is that going to give us? In our first step, we have our potassium phthalimide and our bromopentane, and that's really simple reaction that's going to happen. Is because remember this nitrogen is negatively charged, this one right here, so it's pretty nucleophilic. He wants to go offload that, and so he's going to SN2 attack this position right here, pick this up. That primary bromide carbon is very susceptible to nucleophilic attack, and then we are going to be left with this N-functionalized imide here. Sorry for my terrible drawing skills. A lot harder than you think to draw on an iPad very well. So 1, 2, 3, 4, 5. So this is what that gives us. Remember, that's just a simple SN2 substitution reaction. We have a primary alkyl halide, and we have a very nucleophilic nitrogen that's very rapidly going to undergo SN2 reaction. Now, in the second part of our reaction, we have our N-functionalized phthalimide here, and then we have, for a second step, hydrazine. Now, hydrazine actually, structure-wise, looks like this right here. We have we have lone pairs on our nitrogens. Remember, that's always important. So what's going to happen is these nitrogens are going to nucleophilically attack one of these carbonyls, and so this is going to happen. It's going to pop itself right on there, and then through a bunch of rearrangements that I don't really, yeah, like going through right now. I could probably make a whole video on the ending mechanism of this reaction right here. But suffice it to say, you're going to end up with this as your final product. 1, 2, 3, 4, 5. And then where we get, oops, I'm sorry. We get a primary amine as our product. Is this is what's known as a Gabriel synthesis. This is a named reaction, and usually named reactions are very important and useful. So this is a great way to make primary amines, especially alkyl amines. I have used this before in lab during my PhD, and I've also used Gabriel synthesis a couple other ways, not to make amines, but to just put phthalamides on things or attach things to a phthalimide. It's a really interesting reaction, and sometimes it's a little finicky, but it does work. Okay, so we just walked through it, and we'll go through it again as a quick recap. We started with potassium phthalimide, which we reacted with our bromopentane, which gave us a N-alkyl functionalized phthalimide, and then we reacted that with hydrazine, which yielded our final product, which was this primary amine here, pentamine. And so remember, this is a named synthesis, this general reaction setup is a name reaction, and this is called the Gabriel synthesis. And it is for making primary amines. SS. So if you have any questions about Gabriel synthesis, you can just look it up. There's a lot of information on the internet, or you can DM me about it. I can answer any questions. As always, I hope this video is helpful for you guys. If you have any questions or anything you want to see a video on, you can put it below in the comments. You can also DM me so if there's something you got wrong on your exam or something you didn't understand from lecture, send it over to me and I'll try to make a video and help walk you through it.